NEC 2002 Article 110.3b states that an equipment grounding conductor shall be used to connect the non-current carrying metal parts of equipment, raceways, and other enclosures to the system grounded conductor at the service entrance or grounding or electrode system. VFD manufacturers typically specify that the equipment grounding conductor, also known as the EGC, for the VFD should be run separately from the raceway. Using the raceway as the EGC for the VFD is a violation of the manufacturer's installation instructions. It is also a violation of NEC 2002 Article 110.3b if the raceway is not properly grounded to the system grounded conductor or grounding electrode system. Improper grounding can compromise the safety of the installation and equipment. It can lead to shock hazards, equipment damage, or reduced performance. Firstly, insist that the VFD wiring be corrected to meet the manufacturer's instructions and NEC requirements. Secondly, request a re-inspection from the authority having jurisdiction, known as the AHJ, to verify proper grounding. Thirdly, until the grounding is corrected, refuse to provide field service on a liability basis. The electrical contractor may be liable for the cost of correcting the grounding if they were aware of the manufacturer's requirements or the NEC code. The general contractor is ultimately responsible for ensuring that the installation is code compliant and safe. It is important to document all communication and actions taken regarding this issue for legal protection. The equipment grounding conductor plays a vital role in electrical safety by providing a low impedance path for fault current to return to the source. This low impedance path facilitates the rapid operation of overcurrent protective devices such as circuit breakers or fuses, which in turn minimizes the duration of any potential shock hazard and reduces the risk of equipment damage. In the context of variable frequency drives or VFD, proper grounding is even more critical due to the presence of high-frequency noise and harmonics generated by the VFD switching circuitry. These high-frequency components can create significant electromagnetic interference or EMI, which can disrupt the operation of nearby electronic equipment and even lead to erroneous readings or malfunctions. A dedicated equipment grounding conductor helps to mitigate these issues by providing a lower impedance path for the high-frequency noise to dissipate, thereby minimizing the risk of EMI and ensuring the reliable operation of the VFD and other sensitive electronic devices. Furthermore, using the metallic raceway as the sole equipment grounding conductor for a VFD installation can be problematic for several reasons. Firstly, metallic raceways typically consist of multiple sections joined together, and the electrical continuity between these sections may not always be reliable, especially over time, as corrosion or loosening of fittings can occur. This can result in a higher impedance grounding path, which may not be adequate to safely handle fault currents or effectively mitigate high-frequency noise. Secondly, metallic raceways may not be sized appropriately to handle the maximum fault current that could occur in the event of an electrical fault. The equipment grounding conductor must be sized in accordance with the NEC to ensure that it can safely carry the available fault current without overheating or causing a fire hazard. Thirdly, relying solely on the metallic raceway as the equipment grounding conductor can make it difficult to perform proper grounding tests and measurements to verify the integrity of the grounding system. A dedicated equipment grounding conductor allows for easy testing and verification of the grounding path, ensuring that it meets the required performance standards. It is imperative to adhere to the manufacturer's installation instructions for VFD, as these instructions are specifically designed to ensure the safe and reliable operation of the equipment. VFD manufacturers typically specify that a separate insulated equipment grounding conductor should be run in parallel with the metallic raceway to provide a dedicated low impedance grounding path. This approach helps to minimize the risk of electrical shock, equipment damage, and EMI, and it ensures that the VFD installation meets the requirements of the NEC and other applicable standards. When inspecting a VFD installation, it is crucial to verify that the equipment grounding conductor is properly sized, installed, and connected in accordance with the manufacturer's instructions and the NEC. This includes checking the size of the grounding conductor, the tightness of connections, and the continuity of the grounding path. Any deficiencies or discrepancies should be promptly corrected to ensure the safety and reliability of the installation. In addition to the equipment grounding conductor, it is also important to ensure that the VFD is properly bonded to the building's grounding electrode system. This bonding helps to equalize the potential between the VFD and other grounded metal parts in the building, which can further reduce the risk of electrical shock. The bonding connection should be made using a properly sized bonding jumper or conductor, and it should be securely connected to the VFD grounding terminal and the building's grounding electrode system. Proper grounding and bonding are essential for the safe and reliable operation of VFD, and they should be given the utmost attention during installation, inspection, and maintenance. Failure to properly ground and bond a VFD can have serious consequences, including electrical shock, equipment damage, and even fire. Therefore, it is imperative to follow all applicable codes, standards, and manufacturer's instructions to ensure that the VFD installation is safe and code compliant. The NEC provides specific requirements for grounding and bonding electrical systems, including VFD. Article 250 of the NEC covers grounding and bonding requirements, and it provides detailed guidance on the selection, installation, and connection of grounding and bonding conductors. It is essential to be familiar with the requirements of Article 250 when working with VFD or any other electrical equipment. Some key requirements of Article 250 that are relevant to VFD installations include the following. The equipment grounding conductor must be sized in accordance with NEC Table 250.122 based on the rating of the overcurrent protective device protecting the circuit. The equipment grounding conductor must be installed in the same raceway or cable as the circuit conductors. The equipment grounding conductor must be connected to the grounding terminal of the VFD and to the grounding electrode system. All metal parts of the VFD, including the enclosure, must be bonded together to form a continuous grounding path. The bonding connections must be made using listed bonding fittings or connectors. The grounding electrode system must consist of a grounding electrode, such as a ground rod, ground plate, or metal washer pipe that is connected to the earth. The grounding electrode system must be installed in accordance with NEC requirements. In addition to the NEC requirements, it is also important to follow the manufacturer's instructions for grounding and bonding the VFD. The manufacturer's instructions may provide more specific guidance on the proper grounding and bonding methods for the particular VFD model. It is always best to follow the more stringent requirements, whether they're from the NEC or the manufacturer's instructions. When performing grounding and bonding work on a VFD, it is important to use proper tools and equipment. This includes using a calibrated multimeter to measure grounding resistance and continuity, a torque wrench to ensure that connections are properly tightened, and appropriate personal protective equipment, such as gloves and safety glasses. It is also important to follow safe work practices, such as de-energizing the circuit before working on it, verifying that the circuit is de-energized before touching any conductors, and using lockout-tagout procedures to prevent accidental re-energization. Proper grounding and bonding are critical for the safe and reliable operation of VFD, and they should be given the utmost attention during installation, inspection, and maintenance. By following the requirements of the NEC, the manufacturer's instructions, and safe work practices, it is possible to ensure that VFD installations are properly grounded and bonded, thereby minimizing the risk of electrical shock, equipment damage, and fire. In the specific scenario described, the electrician's use of the RNC as the sole EGC for the VFD against the manufacturer's instructions presents a clear violation of NEC Article 110.3b. This article mandates adherence to the equipment's listing and labeling instructions, which, in this case, explicitly require a separate EGC. The electrician's defense of ignorance and the assertion that the installation was done according to the bid and Article 250 do not absolve them of responsibility. Article 250 provides general guidelines for grounding, but it does not override the specific requirements outlined in Article 110.3b or the manufacturer's instructions. The general contractor's dismissive attitude, citing the job's passing a final inspection, is also problematic. While a final inspection might indicate compliance with certain aspects of the code, it does not necessarily guarantee that every detail, including adherence to manufacturer's instructions, was thoroughly scrutinized. Moreover, the passing of inspection does not absolve the contractor of liability for potential safety hazards or code violations. Given the circumstances, the following steps should be taken. Firstly, provide the general contractor and the electrical contractor with written documentation of the manufacturer's grounding requirements and the relevant NEC articles. This documentation should clearly outline the code violations and the potential safety hazards associated with the incorrect grounding. Secondly, insist on a meeting with the general contractor, the electrical contractor, and the authority having jurisdiction, also known as the AHJ, to discuss the issue and agree on a corrective action plan. The AHJ involvement will ensure that the corrective action plan meets the requirements of the NEC and other applicable standards. Thirdly, refuse to provide field service on the VFD until the grounding is corrected and verified by a qualified electrical inspector. This refusal is necessary to protect your company from liability in the event of an electrical incident. Fourthly, document all communication and actions taken regarding this issue for legal protection. This documentation should include copies of emails, letters, meeting minutes, and inspection reports. In addition to the corrective actions, it is also important to address the underlying causes of the problem. The electrical contractor's lack of awareness of the manufacturer's grounding requirements suggests a need for improved training and communication. The general contractor's dismissive attitude highlights the importance of emphasizing safety and code compliance throughout the project. By addressing these underlying causes, it is possible to prevent similar problems from occurring in the future. The financial responsibility for correcting the grounding issue is a matter of negotiation between the general contractor and the electrical contractor. However, the electrical contractor is ultimately responsible for ensuring that the installation meets the requirements of the NEC and the manufacturer's instructions. If the electrical contractor was aware of the grounding requirements and failed to follow them, they may be liable for the cost of correction. A general contractor, as the party responsible for overseeing the project, may also share some responsibility. The specific allocation of financial responsibility will depend on the terms of the contract between the general contractor and the electrical contractor. In the absence of a clear contractual agreement, the parties may need to consult with legal counsel to resolve the issue. Regardless of who bears the financial responsibility, it is essential to correct the grounding issue as soon as possible to ensure the safety and reliability of the VFD installation. Delaying the correction could lead to serious consequences, including electrical shock, equipment damage, and fire. Therefore, it is in everyone's best interest to work together to resolve the issue quickly and efficiently. It is important to remember that electrical safety is everyone's responsibility. By following the requirements of the NEC, the manufacturer's instructions, and safe work practices, it is possible to prevent electrical accidents and ensure the safety of people and property. In the context of VFD installations, proper grounding and bonding are essential for electrical safety and should be given the utmost attention.